Hello everybody, welcome to the 13th video on C++ programming language. In this video we are going to look at C++ structure. In the past videos we have seen simple data types such as integer, float, double, character, boolean. So these are built-in data types. Those are simple type, like they hold one type of data. So it is also possible for a programmer to combine multiple different types of different data types and data types to create a single user-defined data type. So let's see. So if you want to create a combined data structure, or you can use a struct variable. So struct is a keyword. So the structure of so the way to define a structure is to write the keyword structure and then you type the variable name. Here the variable name is employee, and then within the curly bracket declare a set of member variables. These are called member variable. Name, age, salary are member variable of this structure with the name employee. So the first data member name is of type string, the second member variable or the structure variable is age of type integer, and then the third variable is salary of type float. So here you can see this structure holds three different data types: string, int, float. And the declaration of a structure always ends with a semicolon. So to define or to declare a structure, you write the keyword struct and then the name of the variable, the structure variable, which is employee here, and then within two curly brackets write all the member variables that you want to define. Here we just create an employee variable. Usually an employee will have a name, age, and a salary. So we just define a simple declare a simple structure variable. And so here what we have done is declared a structure. This doesn't mean that memory is allocated for this structure. So what this tells the compiler is that the a user has the programmer has defined or declared a structure with the variable name employee, and that has three member data. The first one is string, second one is integer, and third one is float. That's all it says. So then within the main function we actually define the employee variable. So if you want to define a variable, then you write the name employee and then write the name. So this is equivalent to declaring an int of type var1. So this is defining an employee variable is equivalent to defining an integer variable like this. So you write the type of the variable. Here it is employee, and then write the name of the variable, which is my employee here. So at this point the compiler allocates the memory for this variable. So the memory will have enough space to store a string variable, integer variable, and a float variable. So this line is normally called defining a structure variable or creating an instance of this employee structure. Either you can say creating an instance or defining a structure variable. So to access each of these members, what you do is you write the name of the variable, my employee, then you use a period to access each of these member variables. So you type the name of the variable, name of the structure variable, that is my employee here, which is this one, and then a period, and then the first member is name. So my employee dot name access this variable, and you assign John And the second one is age, so my employee dot age, and you assign a value of 30. And then the third variable is salary, so you to access salary, what you do is you type my employee dot salary equals 10.5. So this is how you initialize each of these member variables in a structure. And then if you want to print the values, what you can do is cout employee name is equal to access the name, you type my employee dot name. To access the age, you type my employee dot age. To access the salary, you type my employee dot salary. So let's run it and see what we get. Okay, so the first line prints my employee equals John, the second line prints my age or employee age equals 30, and the third line prints my employee salary equals my employee dot salary, which is 10.5. So I hope the structure is clear, but we will look at structure in more detail in the future lectures. Thank you.